My name is Wassim Fourati. I am a science team lead at Infor. And in today's presentation, I'm going to talk to you a bit about Infor Augmented Intelligence services. I will also try to show you a couple of use cases, how we can actually create value with our AI solutions. Now, I apologize, my content is only in English, but if you guys have some questions in French, I can try to answer. So let me start with today's agenda. So I'm going to start, as I said, by introducing what are Infor Augmented Intelligence services. Now I'm going to show what we will focus on and how we create value and how we can help you adopt AI seamlessly. Also, I'm going to go through our solution overview in a way, what's our high-level architecture, just to give you a high-level overview of where will our solution be. And I'm going to go through our AI implementation journey. What will you expect when we partner with you in terms of steps and everything? And finally, I'm going to go through a couple of business applications, showing some 2 or 3 use cases. And these are 2 or 3 solutions of the many AI solutions we have implemented before. So let's dive in and start with what are Augmented Intelligence services. So Infor Augmented Intelligence Services, or AIS, is an AI service designed to partner with businesses and organizations to uncover high-impact opportunities and deliver results quickly. What sets us apart is our focus to make AI accessible and practical for your business. In fact, in as little as 90 days, we can deliver actionable insights that will help you make better business decisions and automate processes and so on. The best part is that you do not need an in-house data science or AI team, nor you would need to worry about all the complex infrastructure to run those fancy machine learning algorithms. Everything runs seamlessly in Infor AI and Infor OS. You get to drive business outcomes from the beginning without having to worry about any of the technical complexities. What AIS brings to you is collaboration with impact, expert guidance and insights, and also a library of proven solutions through incremental success. So we start by working with you to identify your most impactful and prioritize your most impactful AI use cases. Our goal is to deliver AI results that matter efficiently and quickly. So you will also get access to a team of AI and data science experts that will guide you every step of the way, from design to implementation to ongoing optimization. This eliminates the need that you will need to have in-house costly AI experts while maintaining access and gaining access to a world-class AI expertise. So for that, we leverage our extensive AI library, or extensive library, of tried and tested AI solution and business best practices. This allows you to adopt AI incrementally, ensuring a smooth transition by tackling each use case. Now, ultimately, what Augmented Intelligence does, it helps businesses like yours unlock the potential of AI. We help driving adoption quickly. We help generating results just from the beginning. So whether you're looking to optimize processes or operations or reduce costs or just gain some data insights on a specific use case, Infor can set you up for success. And in this presentation, I will demonstrate how we can do that. So first, let's define what's augmented intelligence and how does it relate to AI. So AI, as in artificial intelligence, is a broad concept to make machines intelligent. It includes machine learning, it includes robotics, computer vision, optimization, and all that. Now, in machine learning, which is most of our solution based on, is an application of artificial intelligence that focuses on building systems that can learn and optimize from data without the need to be explicitly programmed. Deep learning was famous I mean, it's still very good, but it's a subset of machine learning that focuses on building deep neural networks that can learn from data. And now the trend, generative AI or Gen AI or LLM-based models, which focus on creating content, complex content based on images, text, and videos, and it creates these contexts as well. So our augmented intelligence services comes in and link all these domains to people and businesses. We focus on creating that relationship. So it's an alternative conceptualization of artificial intelligence that focus on human-centered partnership model of people and AI. That's how we would define this augmented intelligence. Let me quickly stop if you have any questions before moving in on solution overview. And we're going to start by seeing the high-level architecture of our solution, how these, where our AI models will live, and then we're going to go through our AI implementation journey. All right, let me quickly go to the next slide. So let's start by introducing this high-level architecture overview, where this machine learning, this brain of the solution will live. It will be under Infor AI as part of Infor OS. So this is where we train this machine learning model. This is where we create these mathematical transformation and all that stuff. Now, our solution are data-driven, so we need data for that. And this data will be in data lake, safely stored, where the model will load data from there through querying efficiently and store data back there. Also, there will be workflows that will take care of running the solution end-to-end, from getting data to doing all those transformation, cleaning the data, to training the model, generating prediction, post-processing, etc. IonDesk will handle the creation of workflows that will either run on a schedule, if you would like them to run daily, weekly, monthly, whatever that business case requires, or on demand if that's required. Now, whatever your input data is in ERPs, on-prem, on cloud, if you need any third-party data source, IoT data, there will be a wide range of enterprise and business connectors that will allow to pull that data in and send the results back safely to wherever you would like them to be. Now, our solution runs in batch. In a way, you generate full loads of prediction for your full data once every day or every week, whatever that business requires, or in real time. So you can retrieve real-time output from an endpoint. There will be an endpoint up and running from which you can query and get the results immediately. On top of that, we build business action layers. This business action layers help add in explainability, help add in insights. It's not just raw results. We actually want to give you the insights that will help you enact on those results. And these results can be analytics, home pages, email notification with alerts, Mongoose dashboards or other dashboards. There we can build chatbots, Gen AI chatbots that will help you summarize the results or get, specific insights on certain results or filter them. We can send the data back to ERPs, actually, where it will be followed up by other processes. Or if there's a third party that can be supported, of course, we can still send data there. Next, I'm going to walk you through AI implementation journey. So when we partner with you, what you would expect in terms of steps and milestones, if I would say. So first, we identify your problem. As I mentioned before, we focus on creating results that matter with great value. We want to identify a problem that will actually is a pain point in your business process. We want to make sure there is data for it so that we can run the solution, and also make sure it will create value to it, and we have the solution for it. So once we go through this session and we define the scope of our problem, and we establish definition of success and value proposition, we move to exploratory data analysis. And as data scientists, that's what we love to do, pretty much dig into data. There, we try to identify all data issues, data anomalies, data inconsistency, if there is enough data for the solution, and so on. But also, we work on identifying trends, seasonalities, identifying features that will be implemented later and will be relevant to the solution. Now, the next three steps, I think they are in gray box, but might not be clear on the slide, but the next three steps can vary from one use case to another. But in a typical machine learning-based solution, this is how it looks like. We have staging observable, which is mostly machine learning related. And we're going to define stuff like create an intersections, train set, test set. If you're familiar with machine learning, you know these. So pretty much these are steps we do and we automate that will be needed later to train the model. Then feature engineering. And this is very important. This step pretty much is, in my opinion, the most important part of building a model in a way that it transforms your raw data in whatever format it is through mathematical transformation and algorithmic transformation into a new format of data, columns and features that pretty much we can say the model can understand them and generate prediction based on them. So that's the feature engineering, where we create feature that will be very helpful in improving the accuracy of your model, etc. Then we tune the model. Pretty much we choose, there's a bunch of machine learning algorithm we choose from with a certain configuration and that stuff. And throughout this whole process, we follow an agile process in a way that in every step of the way, we will share our progress, we will share our findings, we will share our assumptions, and we will look to hear from you to get feedback if our assumption is correct, if we can improve certain steps, and so on. So we share our progress in every step, and we share with you the value proposed of the model, like how much do we expect to generate value from this. And once we finalize the model and test it thoroughly, we deploy it to production and we'll take care of that. Pretty much we deploy it along with the workflows I mentioned earlier. So everything will run end-to-end without having need to worry about any technical complexity. After deploying the model and it's running on a regular basis in production, we will also follow up, get feedback on the output, I would say, but follow up accuracy and the value generated in a way that we will try to monitor and set up feedback for continuous model improvement and continuous optimization. I'm going to stop here for a bit if you guys have any questions. Good, all clear?
I have a question.
Yeah.
I don't remember. Velocity, what's the difference between this and the velocity thing that was presented this morning?
It's a different service that we offer, but I think it's follow the same principle, but it's a different service. It's Augmented Intelligence service focuses mainly on building custom artificial intelligence for you. So that's where we partner with the business, where to actually understand a specific business need, and we build machine learning and artificial intelligence for it. It's Velocity, as Max showed in the earlier, it follows our processes and all other stuff, but here we focus on, it can be something totally different that we want to focus a problem, specific business problem. Like I'm gonna showcase a couple of use cases later, where we do inventory optimization or recipe optimization and all that stuff.
So is it okay to say that the velocity things are maybe all the things that were done many times that can be like more or less prepackaged into a product that is usable by many people, and you're doing the custom work, specific business needs in a custom manner?
Yes and no, but I would think that Velocity, as we said earlier, it actually packages things if they're repetitive, but we also do the same, but for a different set of solutions, a different set of services. We not necessarily have packages that you can use out of the box. I mean, if we create those templates, as we call them, in a way to help us get a head start. So when we start with a new customer, we can get to the end goal much faster. We still focus on understanding specific business requirement and incorporate the feature either to the template directly or maybe do some customization for you. All right? Yeah, sorry.
Quick question. Since last night, we discussed how can we really leverage AI when a customer will want to migrate from mine to the cloud. And it's some clean up process, clean up of data, things like this. I understand the recipe is not there, but can we have a use case that we can use and leverage this type of solution?
Potentially, yes. I mean, we would have to divide this problem into some other sub-problems when we can focus on. So, for example, we have tools for outlier detections and data quality checks that we can implement for that specific purpose. I mean, we identify the input and output for that. We don't have something ready that will bring up everything from on-prem to on-cloud or identify all these processes, but if we divide it to sub-problems, potentially, sure, we can create these to solve them.
Okay, but the sub-question, you said that you have use case already integrates cleanup data. I know if I use the right term, but if you have this use case available that we can, I understand you don't have the full package, I got it, but with the sub use case, do you have any available right now that we can be liberated?
Available, like
you said that you have something to clean up the data.
Yes, we have. So our solutions, I'm going to show one, like we'll try to solve a bigger problem.
I'm outside of your presentation.
No worries.
Okay.
So, but we have some engines, as we call them. We have regression engines, outlier detection engines. These are some machine learning engines that we use to get a head start and try to solve, for example, if you would like to clean up some data. So we get a head start by using these engines to start. This engine would still require configuration and some setup to link up everything and get the right parameters and increase accuracy. But we have these available that we can implement faster.
Okay.
They're not ready to use out of the box, but it's more of engines that help experts when they will help us when we actually build the stuff to configure much faster.
Okay. That's not it, but the message is we have to be some opportunity.
Yeah, I would agree with you on that point.
Okay.
All right, any more questions? Okay, so let's start on a couple of business applications. I chose two to start with. First one would be inventory optimization. So inventory management in general can be very difficult and tricky to manage, especially finding that balance between supply and demand, whether it's inbound inventory or outbound inventory, is very difficult. So finding the right inventory levels while minimizing surplus or excess inventory and maximizing service level can sometimes feel like walking on a tightrope. It's very difficult to find that balance. Now imagine doing that for hundreds or thousands of products or items across multiple locations, and the problem gets exponentially more difficult. Planners usually are good to leverage their experience in actually finding best inventory strategy, but for a few selection of items, they cannot go through every single item and do that manually. And that's where our solution comes in. It's flexible, it's configurable. Our inventory optimization solution helps generating the optimal policy for each item location or for each intersection you're interested in. Now, let me take a step back and define what's inventory policy. I've been mentioning it, or inventory strategy. So to maintain certain inventory levels, we usually try to follow certain strategies. So for example, you need to maintain certain level of safety stock, or you follow an RQ policy and you use a certain reorder point and order quantity, or you're using a min-max policy and you keep a min value and a max value. So these are examples of the many policies that this inventory optimization solution can output, but it's not just defined, but like I'm going to say you're going to do safety stock for everything. It can actually be dynamic and configurable enough to have a different policy for each item location. And we've recently implemented this solution to a global distribution and manufacturing customer, and we were able to, for car parts, and we were able to achieve about 5% of reduction in holding costs while maintaining the service level roughly as they are, especially for their most important items. But let me go through the capabilities and what this solution does. So first, the goal here is to maximize inventory efficiency. So our aim is to generate optimal inventory policies. And for that, in addition to the state-of-the-art inventory policy generation tools, there's some state-of-the-art, some formulas in literature, some iterative algorithms and all that stuff. We have an optimization layer that runs advanced optimization algorithms to find the right policy for each item location given certain constraints and configurations. Now, you're wondering how do we, especially any of you who worked with inventory or these inventory policies, you're wondering how can we measure the value of an inventory policy before we even try it? And that's true, that's a huge challenge. In general, estimating how an inventory policy would perform before actually trying it out and seeing how it performs can be very difficult. And for that, we added an advanced optimization tool. It uses statistical measures and the intricate relationship between historical demand, historical lead time, uncertainty in supply chain, uncertainty in demand, and all other item and location attributes to simulate hundreds of demand scenarios in the future. The most likely scenarios that will happen in the future, it will simulate hundreds of them, and will simulate each policy it's trying to evaluate in the future. This way, it can output various KPIs that will help us assess if a policy is good or bad by giving us, like, for example, what will be the average holding cost, what's the average inventory, what's the service level, etc., and many other KPIs that can be derived from this measure. This simulations is not only run on the system-generated policy, the one that's the output. So one of the things I mentioned that we try to do is drive adoption. And to drive adoption, we want to make sure the user of our solution has the right insights to trust whatever we're delivering and use it, actually. We want to make sure that at some point they use only our predictions. And for that purpose, we can evaluate not just the system policy, but a benchmark policy in many cases. And in most cases, customers choose to use their current inventory strategy that they're using. This way, the user will have KPIs for their current policy, how it is performing, and the system policy. And they can choose to switch into, change their inventory strategy to switch into the new result, or choose something in between, maybe. This, and as you can see in the right chart, we have created a dashboard on top of these results. So we have these KPIs on top that are pretty much average inventory cost or average holding cost to give a high-level overview, executive overview, but also it can drill down to any level of the hierarchy you'd like to have. So if you want to look at it by, I don't know, item group or by location or region, all that still would be possible. But also what I wanted to mention, you can see it's not so clear, but you can see blue and red charts, which compares the system policy versus the current one to help users trust whatever results they found. So if they see for certain items that the new policy is performing better, they can switch to the new one. If they see a slightly worse result that they don't trust, they can choose something in between. The goal here is to drive adoption quickly. So I forgot to mention one thing. The solution is super flexible and configurable in a way that one thing we do to drive adoption is that add certain constraints. Some users, either this use case or any other, if you give them results different or strategies or output different of the processes they have today, they tend to resist this result. So they tend to refuse it. So we add certain constraints based on the specific business discussions that we translate into data-driven these constraints and configuration to help control the output in some way to make sure the users or our customers trust these results and actually implement them fast. Also, you can see in the bottom chart, we have like scatter plot, and this one, for example, compares holding cost change to service level change. These are example of charts that we use for this solution and other to track the health of our output. We want to make sure that our solution gives accurate output continuously. I mean, even if we deploy it into production, we keep looking at this dashboard and make sure everything is right. Before I move on to the next use case, any questions here? Yeah?
Roughly how long from start to finish for this project?
I would say 90 days. In as little as 90 days, we can reach the start from start to finish. Then if you'd like different configurability, if your problem is simpler or slightly more complex, things can move faster or slightly slower. But we usually our benchmark is 90 days to deliver stuff. All right, next use case, I'm gonna go through a use case we've been working on for a while now. And it's we worked in collaboration with CalTire, which is global dealer in mining tire services and supply. So in this, we're trying to predict service need, and it's part of a bigger library of solutions called Asset Health. In Asset Health solution in general, what we try is to maximize the health of an asset. We want it to run as long as possible by predicting the right maintenance windows and the right time to change parts and the right downtime events. So back to our customers, they have many mines all around the world. And among these mines, they had some problems that they changed tires too soon and or too late, or they change tires too often so that they have to stop trucks a lot. And I'm talking about mining tires, so huge tires, extremely expensive and very difficult to get from one location to another. So every minute matters, and stopping the truck every minute matters. Now, our solution goal is to maximize the asset of life cycle. And for this, we used machine learning to use the historical maintenance data along with the historical data of all their trucks, and used different data sources such as meter readings, some IoT data, site prediction, and inspections actually, to generate the right prediction. And by right prediction, I mean we predict when a tire is due for rotation. You want to move the tire from this position to the other one, from the front to the back, for example, or for scrap. This tire is done, pretty much you need to scrap it and install a new one. This, in addition to this prediction that helped a lot the planners, we added a layer of optimization in which we try to decrease the downtime events. And by that, I mean, we want to minimize the number of stops. So we added an advanced optimization algorithm that runs on top of that with goal to minimize the number of stops, to keep certain levels of spare tires, because you want to keep tires always in stock in case of emergency. In case a tire blow up, you need always to have a tire to change immediately and keep working. And take into consideration also site capacity. You cannot change all tires on the same day. These are huge tires, it takes hours to change just one of them. And with that optimization algorithm, we were able to reduce maintenance downtime by 20%. Now, our prediction, we have been working with this customer for a while, so we know the adoption scale for it. So our predictions and our optimization output allowed it to go full-scale tire planning automation in a way that our predictions go to all sites and they have all the work orders created. Of course, they can look at the all work orders, when to change tires and everything. They can adjust them, but everything is automated in how it's now being generated. And this is a use case for tires, but we have our asset health solution that can be applied to any other machines or any other tools that's used in industry or in production. Any questions so far? Yes, please. So this is asset health solution. In a way, it's a solution that tries to predict the asset health. By predicting asset health, we estimate when it needs to be, when it's due for maintenance or when it's due for repair and all that, using historical maintenance data and using different other attributes that can include IoT data, for example. In this case, the asset is tires or positions of the tracks, in which we try to estimate the health of the tire and when to change tire, when to rotate it, when it's due for repair, etc.
But it's not an already solution.
The template is there, but we still need to understand your specific business requirement for that to implement, to make it sure it works for your specific use case. Thank you.
So all the maintenance, you know, maybe it's not there, maybe you already know, what is the impact of the revenue side? Did this dealer increase his revenue? I saw that they don't time the reduction as the percent of cost reduction. What about the revenue? Let's create new sales, basically. Maybe you don't.
I don't know the value of it. I know it's probably, as you mentioned, since we're reducing downtime event, we make sure that the tires are there in the right moment, but I don't know how much it would generate in terms of value. Sorry about that. So I'm running out of time, so I'll quickly go through the last use case when it's a sorry, go ahead. I apologize, I didn't see.
I just wanted to know if you did it in 90 days.
This one? No, it took longer than 90 days. This is what. This one was, the tire one. Because this was our very first problems we worked on, so took slightly longer. I mean, we implemented the results for, I don't know, I wasn't the part of the project at the time, so I can't really tell, but we kept continuously working on the results and optimizing things, and now the solution is much more mature and ready to be deployed in much less than that. All right, and finally, I'm gonna just quickly skim through the forecasting intelligence solution since I'm running out of time. Now, our forecasting intelligence doesn't does pretty much handles whatever uncertainty you want to predict. So any measure you would like to predict that you're uncertain about its outcome, whether it's demand, whether it's customer behavior, whether it's work hour, whether it's cash flow, our forecasting solution can handle it. And for that, how it does that? Pretty much it's a combination of advanced machine learning algorithm, both time series based and multivariate algorithm. So in time series based, it looks at the history to predict what happens in the future. So it assesses trend, seasonality, and all that stuff. But what sets our solution apart is that multivariate model. In a way, it takes into consideration any kind of data that can drive the demand. For example, looking at events, holidays, attributes of an item, attributes of location. And by looking at attributes, especially of item and location, imagine the case of having a new item, for instance. You don't have any history for it. So we still can predict its demand, for example, given the history of all other items that have similar attributes. And the advanced multivariate machine learning will handle that. This allows to streamline planning and allocation. And obviously, as any of our solution, we don't just give the results as is. We try to build insights on top of that, KPIs, continuously measure the performance through checking the forecast and its accuracy, and checking how it performs and how it keeps performing at the same level. So when there's a change in the behavior or the accuracy or et cetera, we can check back and see if there's any data anomalies or changes in trends on something that happened like that. Sorry, I'm out of time, but if you have any questions, I will be happy to answer them. Thank you.